Hello, my dear students. Welcome to KU TV Elimu Live. My name is Teacher Kelvin Wanyambura. As we always do, we start our lesson with a word of prayer. Father, in the name of Jesus, we worship you for this lesson. You give my students the understanding that comes from you. In Jesus' name, amen. My dear students, in our previous lesson, we learned about differentiation. And differentiation is a wide topic. So the subject that we are learning is mathematics. The subject that we are learning is mathematics. A very interesting subject. And we did differentiation part 1. So in that part 1, we learned about how to get the stationary point or the turning point of a curve and the nature of the turning point. So today we are going to continue with differentiation, which we'll call differentiation part 2, and we'll look at three things: equation of a tangent to the curve, equation of normal to the curve, and we'll also see how differentiation is applied in kinematics. When I talk about kinematics, I'm talking about displacement, velocity, and acceleration. So to start with, we write the topic. The topic is differentiation. Differentiation. This is a Form 4 topic. On calculus called differentiation. Now, before I talk about the equation of tangent and normal to the curve, I want to remind us how we differentiate. Given a function, y is equal to x to power n. The derivative, that is dy over dx, this is the derivative or the gradient function or the derived function, is equal to, you bring this n here, n, x, then you subtract 1 from the power, n minus 1. So it will be n x to power n minus 1. We are reviewing how we differentiate. For example, differentiate or get the gradient function. Find the gradient function. Find the gradient function of y is equal to x cubed plus 2x squared plus 3x plus 5. Now, how do we differentiate, or how do we get or find the gradient function? You'll say dy over dx is equal to, bring 3 here, 3x minus 1 from the power, so it will be 3 minus 1, 2, plus, bring 2 here, there is another 2, so it will be the 2 you brought here multiplied by the 2 that you met there, that is 4x to power 2 minus 1, which is 1 to power 1, then plus, I said if there is 3x and x has no power, the x ceases to exist. The x ceases to exist, and therefore here we'll just have plus 3. The x has no power. So if you are an x that has no power, you just go like that, and you will leave 3 alone there. Then there is a 5 that has no x. The 5 that has no x ceases to exist. So if you have no x, you just go like that, and therefore our gradient function will be, when the power is 1, you don't write the 1, you just write 4x. So it is 3x squared plus 4x plus 3. So my dear student, I want us to look at today the equation of tangent and normal to the curve. The equation of tangent and normal to the curve, that is what we are looking at. Equation of tangent and normal to the curve. Equation of tangent and normal to the curve. So we're going to have an example, as I explain the steps that are followed when getting the equation of a tangent or equation of normal to the curve. One, the first thing we do is to get the gradient function by differentiating, then getting the gradient, and then working it out the way we work out the equation of a straight line. That is equation of a tangent. Normal, something you should note, my dear student, normal acts as perpendicular to tangent. Normal acts as perpendicular to tangent. So if in an exam you are told, determine the equation of normal to the curve, you are going to treat it as the equation of a line perpendicular to the tangent. Of a line perpendicular to the tangent. Now, we are going to have an example. Example 1. Find the equation of the tangent to the curve y is equal to x cubed plus 2x plus 1. Find the equation of the tangent to the curve y is equal to x cubed plus 2x plus 1. X cubed plus 2x plus 1 at x is equal to 1. At x is equal to 1. At x is equal to 1. X cubed plus 2x plus 1 at x is equal to 1. Solution. So what is the first step? You have been given the equation of the curve. The equation of the curve is y is equal to x cubed plus 2x plus 1. We are also given the value of x in this equation. The value of x is equal to 1. So, which value don't we have? We don't have the value of y. So, my dear student, the first step, if you are just given the value of x and you're not given the value of y, you will first find the value of y. So we get the value of y when x is 1. We have already been told, find the equation of the curve at x is equal to 1. Therefore, where there is x, in this equation, you substitute with 1 to get the value of y when x is 1. So, 1 cubed plus 2, 1 plus 1. So, this will give us y as 1 cubed is 1 plus 2 times 1 is 2 plus 1. 2, 3, 4. Our value of y is 4. Now, we have, my dear students, we have the value of x and the value of y. The value of x, therefore the point, we have the point. The point 1, 4. The point that we have is 1, 4. X is 1, then we have already gotten the value of y, which is 4. So this is the point that we are going to use to get the equation of the tangent to that curve. After getting the value of y and forming the point as 1, 4, you now get the gradient function. This was step 1. Step 1 is getting the value of y when x is 1. Step 2 is getting the gradient function. Getting the gradient function. So how do we get the gradient function? We already have our equation. Y is equal to x cubed plus 2x plus 1. The gradient function is the derivative of this equation or this curve that we are given, which is dy over dx. This is the gradient function, which is equal to, we now differentiate this. We differentiate this. This 3 will come here, 3x, subtract 1 from 3 to power 2, plus, there is a 2x. X has no power. If x has no power, we're saying that the x ceases to exist. So we'll have 3x squared plus 2. This is what we call the gradient function. That is what we call the gradient function. Differentiate to get the gradient function. Step 3. Step 3, get the gradient. Get the gradient. Now, how do we get the gradient? We already have the gradient function dy over dx. We already have dy over dx as our gradient function, which is 3x squared plus 2. So in our gradient function, where we have x, we substitute with the value of x that is given in the question, which was 1. So our gradient will be 3 1 squared plus 2. Why 1? Because we are told x is equal to 1. Therefore, in your gradient function that you got by differentiating the equation of the curve, you substitute with the x that you are given in the question. And therefore, my dear student, our gradient will be equal to 3 plus 2, which is 5. That is step 3, getting the gradient function. And then getting the gradient. After getting the gradient, now we come and take our point. We come and take our point. Our point was 1, 4. Our point that we got in step 1 was 1, 4. A general point x, y. And the gradient we have gotten is 5. So you come and get now the equation. Change in y over change in x. Y minus 4 over change in x. X minus 1 is equal to the gradient 5 over 1. 5 is the same as 5 over 1. You cross multiply. Therefore, you will have 1 times y minus 4, y into bracket y minus 4, 1 into bracket y minus 4 is equal to 5 into bracket x minus 1. Open the bracket. 1 times y is y, 1 times 4 is minus 4, is equal to, open the bracket, 5 times x is 5x, 5 times 1, and then there is a negative here, so it will be minus 5. Now we have y minus 4 is equal to 5x minus 5. Take 4 to the other side. You'll have your equation as y is equal to 5x minus 5 plus 4. And your answer will be y is equal to 5x minus 5 plus 4 is the same as minus 1. Negative 5 plus 4 is negative 1. So the equation of the tangent is y. This is the equation of the tangent to the curve is y is equal to 5x minus 1. That is equation of tangent to the curve. Now, my dear student, we're going to have a second example where we are going to get the equation of normal to the curve. Example 2. Okay, having understood how to get the equation of the tangent, then getting the equation of normal will be very easy. Example 2 will be find the equation of normal to the curve, y is equal to x cubed plus 2x plus 1. That is normal to the curve. Solution. Step 1, my dear student, is at x is equals to 1. Find the equation of normal to the curve y is equal to x cubed plus 2x plus 1 at x is equals to 1. So step 1 again will be getting the value of y when x is 1. So we have y is equal to x cubed plus 2x plus 1. So getting the value of y when x is 1, y is equal to 1 cubed plus 2, 1 plus 1. So y is equal to 1 plus 2 plus 1 and y is equal to 4. So we already have the value of y when x is 1 and therefore we have the point. We have the point is x is 1 and y is 4. We have gotten the point. Step 2 again. Step 2 now will be getting the gradient. Getting the gradient of the tangent. Getting the gradient of the tangent. Getting the gradient of the tangent. Remember, normal is perpendicular to the tangent. So we must first get the gradient of the tangent and then we treat it as perpendicular to get the gradient of normal. So step 2 will be getting the gradient of the tangent, where again we'll come and get the gradient function dy over dx is equal to, we differentiate our equation, which is y is equal to x cubed plus 2x plus 1. We differentiate dy over dx is equal to 3 comes here, 3x to power 2, we minus 1 from the power, plus 2. Then we get the gradient. That was the gradient function. We get the gradient of tangent. The gradient of the tangent will be 3, where there is x we substitute with 1 because we were told that x is equal to 1. 3, 1 squared plus 2. So the gradient of the tangent is 5. Now step 3 here, step 3 will be now getting the gradient of normal. This is the gradient of tangent. Now we need to get the gradient of normal, which acts as perpendicular to the tangent. So getting the gradient of normal, getting the gradient of normal, getting the gradient of normal. So getting the gradient of normal, we treat normal as perpendicular, therefore we'll say the gradient of line 1, m1 times m2 is equal to -1. In form 2, equation of a straight line and gradient, we said that if lines are perpendicular, then the product of their gradient is equal to -1. So now the gradient of tangent, that is 5, multiplied by the gradient of normal that we don't know, we call it m2, is equal to -1. So 5 m2 is equal to -1. Divide both signs by 5, divide both signs by 5, m2 is equal to -1 over 5. Getting the gradient of normal, which is perpendicular. Let me write into bracket, perpendicular to tangent. Perpendicular to tangent. Gradient of normal, perpendicular to tangent. And we have said if they are perpendicular, I said normal is perpendicular to tangent. So the gradient of tangent times the gradient of normal is equal to -1. The gradient of tangent was 5. The gradient of normal, we call it m2, is equal to -1. Divide both sides by 5 and you'll get m2, which is the gradient of normal to the curve. After getting the gradient of normal to the curve, you come now step 4 and pick the point that you got in step 1. Pick the point that you got in step 1. The point that you got in step 1 was 1, 4. You pick that point. Then you pick a general point xy. Pick a general point xy. And the gradient, we have gotten -1 over 5. -1 over 5. So now we'll be able to get the equation of the normal to the curve. Change in y minus 4, y minus 4 over change in x minus 1 is equal to the gradient, which is negative 1 over 5. Negative 1 over 5. You cross multiply. Cross multiplication means 5 multiplied by y minus 4 is equal to negative 1 multiplied by x minus 1. Open the bracket. 5 times y is 5y minus 5 times 4 is 20 is equal to negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1. We take 20 to the other side. Take 20 to that side. We will have 5y is equal to negative 1x plus 1 plus 20. Then we have now 5y is equal to negative 1x plus 21. Because it was negative, when it goes to the other side, it becomes positive. We divide everywhere by 5, divide everywhere by 5 by 5. Therefore, our y will be equal to negative 1 over 5x plus 21 over 5. And this is the equation of normal. This is the equation of normal. So the important thing to note is that find y when x is 1. Get the gradient of the tangent by differentiating the equation and substituting x with 1. Get the gradient of normal by treating it as perpendicular to the tangent. m1 times m2 is equals to negative 1. Pick the point that you got in point 1, step 1, and a general point xy, and the gradient negative 1 over 5, and then you'll be able to get the equation of normal to the curve. My dear student, that is all about equation of normal and tangent to the curve. We are going to the next section of differentiation, which is application of differentiation in kinematics. Application of differentiation in kinematics. So, application of differentiation in kinematics. What does kinematics means? This means application of differentiation in displacement. Another name for displacement is distance. Another name for distance is height. And it's expressed in meters. The SI unit is meters. The short form of distance or displacement is S. We have velocity. We'll be talking of velocity, which short form is V, and the SI unit is meters per second. SI unit is meters per second for velocity. Another name for velocity is speed. Then we'll also look at acceleration. Acceleration, the short form is A, and the SI unit is meters per second. NB, or some important things to note on kinematics. NB, in this case, anything initial, NB1, initial means t is equal to 0. If you are asked, get the initial velocity, it means get the velocity when time is 0. Determine the initial distance, the initial acceleration. It is acceleration when time is 0. Another thing we need to note is at rest, momentarily at rest, or instantaneously at rest, velocity is equal to 0. At rest, momentarily at rest, and instantaneously at rest, then velocity is equal to 0. Another thing is at maximum height, at maximum or minimum. Not only maximum, but also minimum. At maximum or minimum height, height is also displacement, and it is also the distance. At maximum height, velocity is equal to 0. And lastly, at maximum or minimum velocity, at maximum or minimum velocity, acceleration is equal to 0. At maximum or minimum velocity, acceleration is equal to 0. Those are important concepts that you need to note on the application of differentiation in displacement, velocity, and acceleration. Let us have one 10 marks example so that you may understand better. The displacement S meters. So we're going to do an example. The displacement S meters of a moving particle. The displacement S meters, example 1. The displacement S meters of a moving particle, is given by S is equal to 2t cubed. S is equal to 2t cubed minus 5t squared plus 4t minus 5t squared plus 4t plus 2. Then we are told the initial velocity of the particle that is determined. So question A, determine. So you are told determine. Question A, the velocity of the particle when t is equal to 2. The velocity of the particle when t is equal to 2. Solution. We first do A. We are given the displacement S meters. There is something I want us to note here where we wrote all these. Going this way, going downward, we have displacement, which is the same as height. We have velocity, we have acceleration. So if given the displacement and you are asked velocity, you differentiate. Diff means differentiate. So given the displacement and you are asked to get velocity, you differentiate. Given velocity, you are asked to get acceleration, you also differentiate. So already we are given the equation of the displacement. S is equal to 2t cubed minus 5t squared plus 4t plus 2. And we are told to get the velocity. So we have to differentiate the distance or the displacement and say ds over dt, that is the derivative of s, will give us the velocity, which is this 3 comes here, meets with 2. 2 times 3 is 6t minus 1 from 3 to power 2 minus this 2 comes here, meets with 5. 5 times 2 is 10t to power 1, then plus the t in 4 has no power, so it ceases to exist. So it will be plus 4. So then we are being asked to get velocity when t is 2. We already have the equation of the velocity now. After differentiating the displacement, we have the equation of the velocity. So where there is t in this equation, we substitute with the 2. So we'll have v is equal to 6, 2 squared minus 10, 2 plus 4. So our velocity, when you calculate, you just press in the calculator and insert the values the way they are. 6 2 squared minus 10 2 plus 4. It's giving us 8 meters per second. 8 meters per second. That is the velocity. That is the velocity of the particle when t is equal to 2. Very, very fast, my dear student, we go to part B of the question. The value of t when the particle is momentarily at rest. The value of t when the particle is momentarily at rest. That is part B. Part B, the value of t when the particle is momentarily at rest. Solution. So my dear student, in our formulas we said at rest, either momentarily at rest or instantaneously at rest or at any rest, v is always equals to 0. So this question is simply asking us to get the value of t when velocity is 0. In part A, we have already gotten the equation of velocity, which is v is equal to 6t squared minus 10t plus 4. So we might get two values of t, because if this is a quadratic equation and we equate to 0, we'll get the values of t. So it will be the values of t when the particle is at rest. So we now equate this to 0. 6t squared minus 10t plus 4, we equate to 0 and solve for t. We equate to 0 and solve for t. So we are going to use the product sum factor. The product here is 6 times 4, 24. The sum here is negative 10. You know the product is the first times the last. The sum is the middle one. The factors are two numbers. When you multiply, you get 24, and the same two numbers, when you add, you get negative 10. So we look for two numbers that we multiply, we get 24. When we add them, we get negative 10. And those two numbers are, we can try to get the factors of 24. We can try to get the factors of 24. Like 24 is 12 times 2. Now 12 times 2 is 24. Okay. When we multiply by 12 times 2, you'll get 24. But when you add, you'll not get negative 10. So that one will not give us. Other factors are negative 6, and negative 4. When you take negative 6 times negative 4, you'll get positive 24. When you take negative 6 plus negative 4, you'll get negative 10. Therefore, our factors are negative 6 and negative 4. So we'll come and say 6t squared, instead of writing negative 10, we write the factors, minus 6t minus 4t plus 4 is equal to 0. So 6t squared minus 6t minus 4t plus 4 is equal to 0. We group them into 2 like that. We group them into 2 like that. Then we factor out the common factor. The common factor here is 6t into bracket t minus 1 minus the common factor here is 4 into bracket t minus 1 is equal to 0. So we have 6t minus 4, this one, 6t, the ones outside, 6t minus 4, t minus 1 is equal to 0. So you pick one by one. You pick one by one. So the first one is 6t minus 4 is equal to 0. Take 4 to the other side. 6t is equal to 4. Divide both sides by 6. Divide by 6. Our first value of t is 2 over 3 seconds. T stands for time in seconds. Then we pick the second one. T minus 1 is equal to 0. Take 1 to the other side. Our second value of t is equal to 1 second. Is equal to 1 second. Those are the value of t when the particle is momentarily at rest. When the particle is momentarily at rest, as I said, is the value of v. V is equal to 0 when the particle is at rest. Part C. Part C of the question is asking the acceleration of the particle when t is equal to 5. The acceleration of the particle when t is equal to 5. Now, my dear student, we said if you are asked the acceleration, you differentiate the velocity. We already got the expression of velocity in part A after differentiating displacement. After differentiating displacement, we got the velocity expression, which was 6t squared minus 10t plus 4. That was the velocity expression. So for us to get acceleration, we have to differentiate velocity. So our dv over dt. dv over dt means you are differentiating velocity with respect to t. So it will give us our acceleration expression, which is this 2 here comes here, meets with the 6, and 6 times 2 is 12t. You subtract 1 from the 2, and it will remain t to power 1. And we said if the power is 1, you don't write the 1. Then minus 10. The t has no power, and we said if the t has no power, you leave it as 10 and don't write the t. 4 has no t, and we said if the value does not have t, then it ceases to exist. So it will be 12t minus 10. The t ceases to exist and the 4 ceases to exist because it has no t. So our acceleration, which is 12t minus 10, where there is t, we substitute with 5 because we are asked the acceleration when t is equal to 5. So the acceleration will be equal to 12, 5 minus 10. 12 times 5 is 60. 60, so we'll have 60 minus 10, and our acceleration when t is 5 is 50 meters per second squared. 50 meters per second squared. Now, my dear student, the last question, part D. The last question, part B. Is Okay, so the last question, part D, is when you are asked, part D, determine the maximum velocity of the particle. Determine the maximum velocity of the particle. The maximum velocity of the particle, we said at maximum velocity, acceleration is 0. At maximum velocity, acceleration is 0. So we first get the value of t when acceleration is 0. The value of t when acceleration is 0. Already in part C, we have the expression of acceleration, which is 12t minus 10. So now, you'll come and say 12t minus 10 is equal to 0. We get the value of t when acceleration is 0. Because at maximum velocity, acceleration is 0. So, 12t, take 10 to the other side. It was negative, it will be positive, is equal to 10. Divide by 12, divide by 12. So, my dear student, the question is determine the maximum velocity of the particle. At maximum velocity, acceleration is equal to 0. That is what we said when I was explaining the formulas. So you'll take the expression of acceleration that that we got as 12t minus 10 and equate to 0. So you'll say 12t minus 10 is equals to 0. Then take 10 to the other side. 12t is equals to 10. Divide by 12 both sides. You'll get time at maximum velocity is 5/6. Then this 5/6 you replace in the formula of velocity, which was 6t squared minus 10t plus 4. Where there is t, you substitute with 5/6. And then you'll get the maximum velocity. You'll get the maximum velocity. Thank you. I have seen a comment here. And from Kirinyaga, you are very perfect, Teacher Kelvin. Una explain vizuri sana. You made my son apende maths. Thank you very much. Thank you very much, my dear students. I am an author of 3 books. This is Never Give Up. This is With God All Is Well. And we have Boosting Mathematics Performance, a Mathematics KCSE revision book. If you need to get a copy of those books, you can contact me through 0705-845-747. Thank you very much, my dear student, for being with me. My name is Teacher Kelvin Fude Wanyabura. God bless you, and never forget to pray when you do everything. Thank you.
Fashion. It's more than just clothes. It's a statement, a feeling,